Title of the first section today is Review Graphing Systems. In this section we'll review graphing systems. Systems means there's two or more equations. First two equations we'll graph: y equals 2x minus 3. And the second equation, y equals negative 3x plus 1. Graphing these equations, which are in slope-intercept form. The first equation, we can find what m equals. M is the number in front of x, which would be 2. And if we make that a fraction, it would be 2 over 1. Solving for b, the y-intercept, b would be negative 3. Second equation, m equals, number in front of x would be negative 3 or negative 3 over 1, and b, the y-intercept, would be positive 1. Graphing these equations. The first equation, the y-intercept, is at negative 3, starting at the y-axis on negative 3. The slope is 2 over 1, so we'll go up 2 spots and over 1 spot. Taking these 2 points, we can connect them to get the line for the first equation. Second equation, the b is 1, or y-intercept is positive 1. And the slope is negative 3 over 1. So we'll go down 3, 1, 2, 3, and to the right 1, which will be underneath the other point that we have. Connecting these 2 points, we'll get our line for the second equation. The solution to these equations is the point where it crosses at. Using this graph, we cannot find the exact point. It'll be some decimal. The x value will be less than 1, and the y value will be between negative 1 and negative 2. Without solving this point, we can't solve it by graphing. Later on, we'll use algebra to solve for that point. Second question and last question for the section. We'll have y equals 1/2 x plus 1. And the second equation, y equals 4x minus 2. Again, the 2 equations, we can find the slope and the intercept. The slope of the first equation is 1/2, and the y-intercept would be 1. Second equation, slope would be 4, or 4 over 1, and the y-intercept would be negative 2. Graphing these equations. First equation, we'll start at positive 1 on the y-axis, and the slope is 1/2, so we'll go up 1 and over 2 from the y-intercept. Connecting those, we'll have the line for the first equation. Second equation starts at negative 2 on the y-axis, and the slope is 4 over 1, so we'll go up 4 spots and to the right 1 spot. Taking these 2 points, we can connect them to get our second line. Again, the equation is the point where the graphs cross at. Using this graph, we cannot find the exact solution. The solution would be to the left of positive 1, so the x value would be less than 1, and the y value would be some decimal or some fraction between 1 and 2. But again, we cannot find the exact solution using this graph. Title of the next section is Graphing Systems with no solution, or infinite solutions. In this section, we'll graph systems of equations, which again means two or more equations that will have no solutions, which means the lines do not cross, or infinite solutions, meaning they cross at multiple points. First question and first equation, y equals negative 2x. And second equation, y equals negative 2x minus 3. Graphing these equations, they're both in slope-intercept form. So we can find the slope m. First equation would be negative 2, or negative 2 over 1. And b, the y-intercept, the number after x, if there's no number there, b would be 0. And the second equation, m equals negative 2, so we'll have the same slope, negative 2 over 1, and the b value, or the y-intercept, would be negative 3. Graphing these two equations. First equation, the y-intercept is at 0, which would be in the middle of the graph at the origin. And m equals negative 2 over 1, so we'll go down 2 spots and to the right 1 spot. Connecting those 2 points, we'll have the line for the first equation. Second equation, b equals negative 3, so we'll start at negative 3. And the slope is also negative 2 over 1, so we'll go down 2 spots and over 1 spot. Connecting these 2 points, we'll have our second line. Looking at the two lines, these two lines look to be parallel, going side by side, and if we look at the slope, having the same slope, these two lines are parallel. If you have two lines that are parallel, they'll go side by side and never cross. If they do not cross, then the answer would be no solution. No solutions means these two lines are never equal or they never cross. Second equation and last question for the section. First equation is y equals negative 1/2 x plus 5. And second equation, 2x plus 4y equals 20. The first equation is in mx plus b form or slope-intercept form. So m equals, or the slope in front of x, is negative 1/2, and b equals the last number, which is 5. The second equation is not in slope-intercept form, but we can solve and put this in slope-intercept form. Solving for y, we can move 2x to the other side by subtracting 2x. So we'll have 4y equals 20 minus 2x. We can't subtract a number from a variable, but what we can do is put the variable first, minus 2x, and plus 20 after. Solving for y again, multiplying by 4, the opposite, we can divide by 4. So we'll have our final answer in y equals mx plus b form, dividing each numbers by 4. Negative 2 over 4 will be a fraction. If you reduce that fraction, dividing each number by 2, we'll have negative 1/2 x. And 20 divided by 4 would be 5. Once this equation is in mx plus b form, now we can find the slope, which is negative 1/2, and the b value, which is 5. Looking at the two equations, both equations have the same slope, negative 1/2, and both equations have the same y-intercept, which is 5. Graphing on the xy axis. The first equation again, we'll start at 5. And a negative 1/2 slope will go down 1 spot and over 2 spots. Connecting those would be the first line for the first equation. The second equation again has the same slope and same y-intercept, so we'll have these same 2 points and the same line. which means we'll have a line on top of a line. So you can draw a darker line on top of that same line to represent the second equation. Solving this graph, if we have a line on top of a line, every single point crosses. Anytime you have the same equation twice or the same line, the answer would be infinite solutions, which means the graph crosses at multiple points. Every point on the graph, every point on the line is a solution, so we'll have infinite solutions. Suppose you have $20 in your bank account. You start saving $5 each week. Your friend has $5 in his account and saves $10 each week. In how many weeks will you have the same amount? To solve this question, there are several ways. You could write equations and solve them, or you can also make a table to see where the values are equal. If you start off with, at the beginning of this question, you have $20 in your bank account. And to that $20, we will add $5 each week. And the second part of the problem, your friend starts off with $5 in his bank account. And to that $5, we'll add $10 each week. We can make a column of numbers to see when the weeks will be equal. Starting off with week 1, you'll have your $20 plus 5 more. So you'll have $25 in your bank account, while your friend will have 5 plus his $10, he'll have 15. So after week 1, your friend will have 25, or you will have 25, and your friend will have 15. Continuing the table for the second week until these two numbers are the same. We now have $25, and each time we'll add 5 to that. So the second week we'll have $30, and your friend each time will add $10. 15 plus 10, your friend will have $25. Continuing on the third week, the $30 will add $5 to that. So that would be 35. And your friend will have the $25 plus $10 each week. 25 plus 10 would be 35. These two numbers in week 3, both of you have $35. So the answer to the question, in which week will these same amounts be? And that would be week 3.